Hello, so we are doing Algebra 2, Chapter 6.5, Properties of Logarithms. In the last class, we did some properties. Here we'll do properties of logarithms and logarithmic identities. So these are the properties of logarithms we used in the last class, and these are identities. This is known as product property. This is the quotient property. This is the change of base formula. So when we do the questions, it will become more clear. So let's try it. So this is a question given to us and we have to simplify. So we will use the rules and laws given here. Okay. So for this one, we can use the quotient property here, which is property 3. Okay. And this log 20 can be written as log uh, 4 times 5. We can use property 1 here. And for the third one, we can again use property 3. So let's try doing this. So here we have used property 1. So we used the quotient rule here, and in here we also used the quotient rule. Okay, and this 20 we write it as 4 times 5. Okay, now we will use the product rule. So now this log 4 times 5, we converted into log 4 plus 5. And we have to remember that in all these cases, base must be same. So here base was 10. Then only we can use the product and quotient rule. Now we made 15 as 3 times 5 and we used the product rule here. And also this negative times negative is positive. Now we can simplify it. So now we see that negative log 3 and positive log of 3 cancels. Negative log of 4 cancels with positive log of 4. Now we will simplify further. So we have simplified to here. Now we will use the property number 2 as given here, and we can write log of 4 plus this is log of 5, and this is 5 square. Okay, using this property, and this comes out to be, now you can use product property. So this will give 4 times 5 square, which gives log of 100. Log of base, log base 10 of 100 is. Okay. Now 100 we can write again as 10 square. Okay. Now again we can use this property 2 and we can write this. We know that log of a to the base a is 1 because a raised to power 1 is a. Okay, so this is equal to 1 and our answer is, I hope it is okay, and let me know if you have any difficulty. Let's do next question. So this is question 2 and we have to find expand this and find the domain. So let's expand this using the product and quotient rules we learned. So this, we used the quotient property here and we wrote here and we put the absolute value sign because we know the argument of the log, it should be always greater than 0. It should be always positive. So that's why we put the absolute value sign here. Okay. And now let's further expand. So we know x square minus 9 is equal to x plus 9, x minus 9. We'll use a square minus b square formula. Now using the product property for this, and we will use rule number 2 for x cube log of uh, log base 10 to the x cube 1. So this is log of x plus 3 plus log of x minus 3 and minus 3 log of log base 10 of x. And everything is in absolute value because we don't want argument to get negative. Or so it should be greater than 0. We used this rule 2 to simplify this. Now let's find the domain. So to find the domain, we have to find the critical points at which this either becomes 0 or undefined. We know that argument for this has to be greater than 0. So it means x square minus 9 over x cube, it has to be greater than 0. So critical points here are negative 3, 3 and 0. So these are the critical points, and let's see, because we need to find where this x square minus 9 over x cube is greater than 0. So let's make a table and see. So these are the critical points negative 3, 3 and 0, and we'll check in the which intervals it is positive or negative. So this is x is less than negative 3, so we can have negative 4. So if we take negative 4, x plus 3 would be negative, means anything less than negative 3. So this would be negative. This would be also negative, and this will be also negative. So when we multiply all of these, all the three, the function would be negative. Sorry. Now checking the interval negative 3, between negative 3 when x is greater than negative 3 and less than 0. So we can take any point in between two tests. Suppose we take negative 2. So x plus 3 means anything between negative 3 and 0 would give positive. X minus 3 would give negative. If we put negative 2, it would be negative 5. And anything negative 2 cube will be also negative. So if we multiply all these three, it would be positive. So here it would be positive. It would be greater than 0, between negative 3 and 0. Now let's take any number when x is greater than 0 and less than 3 and test it. Suppose if we take 1, so 1 plus 3 positive, 1 minus 3 negative, and this would be 1 cube would be positive. So if we multiply all of these, the final answer would be negative, means this would be less than 0. Okay, but we want it greater than 0. So now let's test any number greater than 3 here. So suppose we take 4. So 4 plus 3 positive, 4 minus 3 positive, and 4 cube is positive. So if we multiply all of this, we get positive, means this is also greater than 0. So these are the two ranges which gives us, which when x is between these ranges, it gives the positive, and which is greater than 0, and that will be the domain. So we can write the domain in interval notation law. So this is the domain in set builder notation and interval notation. So, and so we've expanded the logarithm given to us, and we also found the domain. Let's do some more problems now. So we have to solve these equation using logarithmic identities given here and find the value of x. And also we have to substitute the values of x and see whether the values work, because we know argument cannot be negative. So let's first use the identities given here and check it. Try to solve the equation. So we used property 2 here and converted into log of base 3 to x plus 4 square, and now we can use the quotient rule which is given in 3 and further simplify this. So this is quotient rule we used here now, and now we'll try to simplify this using a basic log and exponent conversion. So this is log of a base a to x is equal to y will convert into a raised to power y is equal to x, and we use this formula to get here. Now we'll further simplify this. So now we got this 3 square is equal to 9, and this is a x plus 4 square is a plus b square. We got x square plus 8x plus 16. Now further simplifying this, we get this quadratic equation. So now we can factor this. We know 23 times 5 is 115, and 23 plus 5 is 28. So when we simplify this quadratic equation, we get two values of x, which is 5 and 23. So these are the values, these are the solutions of the log equation given here. But it is very important that we test this, okay? Because argument is in a log is always greater than 0, so we should check it. So let's check that. So let's check x is equal to 5 and substitute x is equal to 5 and see if we get the value 2. Now, as we substitute x, we get here 9. 9 can be written as 3 square. So we use this property 2 to write, to convert this into 2 log base 3 of 3, and same here. And this becomes 2 times 2 is 4, and log of, we know, log of base A of A is 1. So we put it here 1. Log of base 3 of 3 is 1. So this becomes 4 minus 2, which is 2. So we got the right hand side. It means this answer is correct. Now let's check x is equal to 23. So we substitute x is equal to 23 and we got 23 plus 4, 27 here, and this 4 times 23 minus 11, 81. Let's simplify and see if we get. So we again simplified this here using property 2, and then we see that log of base 3 of 3 is 1. So 6 times 1 minus 4 times 1 is 2. So we got the right hand side. It means our solution x is equal to 23 and 5 both works. So this is a correct solution. So this is a question given to us, and in this we can use this base change formula, property number 4 or 5. We can use this. So let's try doing this. So we can use property 5 and we can write log of 1 over log of base 10 of 5 is equal to log of log base 5 of 10. And same way for 1 over log base 4 of 5, we can write it as log of log base 5 of 4. Okay. So we can or learn how we derived it. But, we can, since this property is already given to us, the rule, we can apply this. So 4, instead of this, we can use log base 5 of 10. So we used property 5 and we wrote 4 times log 5, log base 5 of 10 minus 2 log, we interchange base and argument, and log base 5 of 4. Now we can use property 2 here and simplify this further. So we used property 3 and simplified this. This we are doing so that we can use the quotient rule in the next step, because both have the same base. So we will be able to use the quotient rule because it's even negative. So 10 raised to power 4 we'll write, and we'll simplify 4 raised to power 2 is 16. Here is the quotient rule, we used it, and this is quotient rule we used. Now we can further simplify. So it is, so on simplifying, this gives log base 5 of 625. Now 625, we know it is 5 raised to power 4. So we can write in this form, and now you will use the property 2, which is this. Okay, and you will write here 4 log 5, log base 5 of 5, and we know log of A, log base A of A is 1, so this is 1 and the answer is 4. Okay, so this value of this equation is 4. Okay, so we'll continue doing more problems in the next class. Please practice and please let me know if you have any difficulty. Thanks for joining.